This is part one of the two micro-lecture series on elements and compounds. Within this two-lecture series, be able to define element, which is the simplest form of matter with a unique set of properties that cannot be further broken down into other elements. Be able to identify compound, which is a substance containing two or more elements, such as sodium chloride or table salt. Compounds contain these elements in a fixed proportion, like for each sodium in table salt, there is one chlorine. Chemical change, we're going to look at that later. Chemical symbol, this is going to be the one or two letter symbol used to represent an element on the periodic table. We're going to look at the periodic table in the other lecture and identify periods and groups in the other micro lecture. Be able to use mathematical representations to support the claim that atoms and therefore mass are conserved during a chemical reaction. This is where we're going to start doing this by being able to identify what atoms are and what elements are. Be able to identify groups and periods on the periodic table. We will get started today and move through multiple lectures on that. Compare and contrast between physical and chemical changes. We covered physical changes in lecture 2.1, and we will be covering chemical changes in lecture 2.3 and many other lectures to come. And last, begin to identify elements. You will be doing this all semester and into the next year. Physical and chemical changes are different things. Water can be boiled. When water is boiled, it goes from being a liquid to being a gas. This is just a physical change. So if you had salt water, you can boil the water, you'll get salt and water vapor. This is going to separate things through their physical properties. Can we separate things further? Well, yes, we can. It turns out if we use electrolysis, we can separate the hydrogens from the oxygens in the water. Well, can we separate things farther? Well, the hydrogen can't really be reduced beyond being hydrogen gas, and the oxygen can't be changed anything else except oxygen gas. So at that point, we have the pure elements, hydrogen and oxygen. A chemical change is going to produce matter with a different composition than the reactants. So if we started with water and then underwent electrolysis, that is a chemical change because what we have then is not water anymore. Now we have hydrogen gas and oxygen gas. These are different things. And we would say in chemical changes, we have these chemical equations where you have on one side the reactants. The reactants are these things you start with. And then you have the products, and the products are the things you end with. A classic example from biology is the equation for photosynthesis. You get 6 carbon dioxide molecules and 6 water molecules, and they are going to form one sugar molecule, C6H12O6, and 6 oxygen molecules. You notice that an oxygen molecule has 2 oxygen atoms in it. This is a chemical equation representing a chemical change where the reactants are different than the products. And you can see how there are numbers involved here such that you have 6 carbons at the beginning and 6 carbons at the end, thus maintaining the same number of atoms on both sides of the chemical equation. Now remember, the reactants are going to be different than the products in a chemical change. Let's take a look at an example of this. Sodium is a metal that reacts violently with water. If you put sodium metal in your mouth, it will react violently, heating up rapidly and giving you chemical burns. 0 out of 10, do not recommend. Chlorine is a gas that bleaches things. If you put it in your mouth, it will react violently with the water in your mouth, forming hydrochloric acid, and will, well, depending on how much chlorine and how long you keep it in, could kind of dissolve parts of your tongue. So, 0 out of 10, would not recommend. Salt, on the other hand, is, if you put it in your mouth, it's flavor. Sometimes the only flavor people get on their food. So it can be put in the mouth quite safely, although you can eat too much salt, but that's true about water too. We are going to break down substances and mixtures here. The first thing we do is we look to see if it has a variable composition or a constant composition. In the previous lecture, we looked at variable composition things. It's mixtures. Now, are these mixtures uniform throughout? Well, no, that'd be heterogeneous, like wet sand, which has water and sand, but at different levels in different parts of the sand. What if it's uniform throughout, like tea, which we know is a mixture because, well, we add sugar to tea, and that's clearly adding something. That's homogeneous mixture right there. What if it does not have a variable composition? Well, then it is a pure substance. It can either be separated into simpler substances, like water could be separated into hydrogen or oxygen, or it cannot be separated into simpler substances, like the element helium. This is the first time we're really seeing an element. So elements are going to be that simplest form of matter with that unique set of properties, helium being less dense than air, being a very important part of that element, a certain